Welcome to class today. Today we're going to be performing some reasoning questions. These are math questions, but they require you to reason properly. In our first question, let's take this question. This question says, how many two-digit whole numbers are multiples of both 6 and 9? Look at this question very well. Anytime we come across this kind of question, this question is related to LCM. So instead of asking you to find LCM of blah blah blah, they will give you this question to see if you understand actually. So let's solve this question. How many two-digit whole numbers are multiples of both 6 and 9? The first thing is to find LCM of 6 and 9. So step 1, LCM. Step 1 is LCM of 6 and 9. So there are a lot of ways to find LCM, but this here is the simplest one so far. So we're going to look for a number that can divide 6 and 9 at the same time. If it's not possible, look for a number that can divide either 6 or 9. So here 3 can divide 6 and 9. By the way, we're using just prime numbers to keep it simple. So if 3 divides 6, we'll have 2. If 3 divides 9, we'll have 3. Okay, there is no number that can divide 2 and 3 at the same time, but we can go in turns. Use 2 to divide 2, we get 1. 2 cannot divide 3, so we still write 3. Use 3 to divide 3, we get 1. Okay, so when we get 1, 1 for all the divisions, we multiply out those factors we used to divide. So in this case, we have 3 times 2 times 3. 3 times 2 here is 6. 6 times 3 is 18. Okay, remember they didn't ask us to find the lowest common multiple. They asked us to find how many two-digit whole numbers that are multiples of 6 and 9. So what this means is that we're going to find all the multiples of 18. All the multiples of 18 are going to be the multiples of both 6 and 9. If you have a number that is a multiple of 6 but not a multiple of 9, no. If you have a number that is a multiple of 9 but not a multiple of 6, no. Okay, it's only a yes if it is a multiple of 6 and a multiple of 9. Okay, and the only way we can do that is by finding the LCM, and then we now proceed higher from that LCM. So what we're looking for are all the multiples of 18. So 18 times 1 will give you 18. 18 times 2 will give you 18 times 2 will give you 36. 18 times 3 will give you 54. 18 times 4 will give you 72. 18 times 5 will give you 90. Okay, what if we have 18 times 6? You see that that number is now a 3-digit number. So we're only looking for 2-digit numbers that are multiples of both 6 and 9. So we have 1, 2, 3, 4, and 5. So there are 5 multiples. Okay, 5 two-digit multiples. There's a condition there. They have to be 2 digits. Okay, and they have to be multiples of both 6 and 9. So anytime you come across this kind of question, you have to find LCM first, and then depending on what the question says, if it says 2 digits, if it says 3 digits, then you know how to adapt to such question. So we have 5 two-digit multiples of both 6 and 9. Okay, let's take a look at another question. Okay, this question is on discount. Okay, we know when we talk about discount, we talk about reduction in price. If, for instance, you went to buy something and the price of such goods is like 10,000, but then the seller says, I'm going to give you a discount of 1,000, which means the seller is going to take away this 1,000 from 10,000 and give you 9,000 for you to buy. So this is what you're going to buy at instead of 10,000. Okay. In most cases, discount is given in terms of percentage. So let's look at this. The question says, in a shop, there is a 10% discount on the original prices of cell phones. There is a 10% discount. If a cell phone has a sale price of 81,000, then what was the original price? Take a look at this question very well. The question is asking what was the original price. That's the price without a discount, which means that the 81,000 is the price after they have removed the discount. Okay, the discount is given in percent here, and it said there's a 10% discount. Now, listen, this is reason this question very well. Okay, there are a lot of formulas to calculate this discount and original price and all of that. But let's reason out this question. Okay, no shortcuts. Let's reason it out. There is a relationship between percentages, discount, and original price. Okay, if you buy at original price, then you're buying at a 100%. Okay, you're buying at 100%. Now, if a seller gives you a discount of 10%, it means that what you're buying at is at 90%. Remember, percent is 100. So if they take away 10 from you, what we make 10, 100 is 90. That means you're buying at 90% of the original price. Okay, so why I'm explaining this, because certain times you will not be asked to calculate discount, rather you will be asked to calculate the price you bought. Certain times you'll be asked to calculate discount. If you're asked to calculate discount, you should also know how to do that. So in this question, since they gave us 10% discount, okay, which means we bought at 90%. And the question is asking us, what was the original price? What was the original price? So let's now calculate. So 90% of that original price is what gives us 81,000. Okay, so it is the 90% of original price. Assuming we know the original price, 90% of that original price is what gives us 81,000. Please follow me. If you don't understand, repeat this video. As time goes on, you will begin to reason. Okay, so I'm trying to build your reasoning in mathematics, not just relying on shortcuts and tricks. 90% of the original price is what gives us 81,000. So since we don't know the original price, we can just assume it as a letter. So let's say 90% means 90 over 100. Let's call that original price y is equal to 81,000. Okay, these are fractions. Okay, so we can solve this fraction. This is numerator. 90 times y is 90y. 90y over 100 is equal to 81,000. Okay, what do you do here? You simply cross multiply. The numerator on the left hand side multiply denominator on the right hand side. Okay, this is not a fraction. Since it's not a fraction, we can make it a fraction by saying over 1. So 90y, we multiply 1, and then 100 we multiply 81,000. Okay, as you can see, this is very simple because the multiplication by 100, we just add the 2 zeros to 81,000. So 81, 3 zeros, then plus the 2 zeros from 100. Okay, and then we'll have 90y. 90y times y is still times 1 is still the same thing. So to get y, we have to divide both sides by 90 because 90 is the coefficient of y. If you don't understand this, then you need to revise your algebra, your basic algebra. Okay, so 81,000,000 divided by 90. Okay, so this 90 will divide this 91, and then we'll have just y left, and then this will take out 1 here. Okay, we know that 9 can divide 81. 9 times 9 is 81, so we have 9 0 0 0 0. So 9 and 4 0. So it means, remember, what is this y? What is this y? Y is the original price. Original price without a discount. So it means that the original price is 90,000 naira. Okay, it's 90,000 naira. So you can confirm if it's 90. If it's 90,000, take 90% of 90,000, you get exactly 81,000. Okay, so let's go to the next question. A rectangle and a square have the same perimeter. A rectangle and a square has the same perimeter. Okay, so this is a rectangle and this is a square. They have the same perimeter. Perimeter means the distance around the boundary of the shape. Okay, so in this question, the length of the rectangle is 10 cm, so 10 cm here. The area of the rectangle is 40 cm square. Take note of that. Okay, so we know that for rectangle, area is length times breadth. Okay, in this case, we're not finding the area, rather we're finding one of the other sides. Since they gave us length, we're looking for the breadth. So we have the area given as 40 from the question, the length is given as 10, and then we're trying to calculate the breadth. So 10 times b is 10b. Okay, here again we go algebra, divide both sides by 10. We'll have 40 over 10 is equal to 10b over 10. Okay, so 10 divide 40, we'll have 4. So b, which is the breadth of the rectangle, is 4. Now if we come here and we have 4 here, it means that here is also 10 and here is also 4, which means that the perimeter of rectangle, you know the formula for your perimeter, that is 2L plus 2B, which if you're very good at factorization, you should know that it is 2L plus B. 2 in bracket, add your length and your breadth together. This is for rectangle. Okay, this is for rectangle. So if we were to solve that, or if you're not familiar with this formula, you can just add 4 plus 10 plus 4 plus 10. Okay, it's as simple as that. So 4 plus 10 plus 4 again plus 10 again. So 4 plus 10 is 14. 4 plus 10 is 14, that's 28. So perimeter for rectangle, please take note that we are calculating for rectangle. Perimeter is 28. Now the question said that the rectangle and the square have the same perimeter. Okay, the rectangle and the square has the same perimeter, which means that the perimeter now for square. Now, how do we calculate perimeter of square? Perimeter for square, perimeter for square is L plus L plus L plus L. Remember that a square, all the sides are equal. So all you need to know is one of the length and you use it for the perimeter. So once we know one of the length of a square, the other lengths are the same thing as that one length. So since we don't know the length yet, but we know that the 4 lengths will give us the perimeter. Okay, And the perimeter has been given as 28. How is it 28? Because they said it's the same thing as the perimeter of the rectangle. So we have 4L's here. So 4L is equal to 28. How do you think I calculate L? This is again algebra. You have to take algebra very serious. There is virtually no question you will not run into algebra. Okay? Apart from arithmetic. One other very important topic is algebra. So divide both sides by 4. We have 4L divided by 4 is equal to 28 divided by 4. And then L is equal to 4 times 7 will give us 28. So it means that length of one side of that square is 7. Okay, so that is the answer to that question. So a father and his 4 children are 36, 2, 4, 5, and 7 years old, respectively. Okay, so when it means respectively, it means that the first one is the father's age, and like that for the children. After how many years will the father's age become equal? After how many years will father's age be equal to the sum of his children's age? Okay, after how many years? Okay, before we solve this question, let's take a look at a few things shortly. I'm not going to spend time on this. Let's assume, just like the question says, that daddy is 36 years. Okay, if daddy is 36 years, and let's just pick one of the age of the child. Let's say one of the child from the question is 2 years. Okay, if daddy is 36 years this year, after 2 years, how old will daddy be? Daddy will be 36 plus 2 years. Okay, so after 2 years, the child will be 2 plus 2 years. How about after 4 years? How old will daddy be? Daddy will be 36 plus 4 years. After 4 years from the initial point, the child is supposed to be 2 plus 4 years. So what we're trying to say is, if you're this old this year, after a number of years, you're going to be your age now plus that number of years. So take note of that, because we're going to use this idea in solving this question. Okay, so we don't know how many years later that the father's age will be equal to the sum of the children's age. Okay, so we can assume that to be x. Okay, so it said after how many years? So we can say let the number of years be y. Okay, so we're not trying to say that after y years, the father's age will be equal to the sum of the children's age. Okay, so if the father's age is 36 this year, in y years time, remember what we just did, in y years time, so in y years time, it means that our father's age will be just 36 plus y. Okay, so that y can be 2 years time or 10 years time, we don't know yet. But what we know is that whatever is going to be, we're going to add that number of years to 36 to know what the actual age of the father is. So in the same way, the child that is 2 years is going to be 2 plus y years in y years time. The child that is 4 years in y years time is going to be 4 plus y years. Okay, the child that is 5 years will be 5 plus y years, and the child that is 7 years is going to be 7 plus y years. Take note of that, it's very important. Now let's consider a very important aspect of that question. It said father's age will be equal to the sum of his children's age in how many years time? So if in y years time the father's age is 36 plus that. It means that what we're trying to say is that this father's age in that unknown number of years time, that is a 36 plus y, the question says will be equal to the sum of the children's age. So in y years time, the father's age is 36 plus y, and in y years time, the children's age are 2 plus y, and then we're going to sum them up, 4 plus y, and then 5 plus y, 5 plus y, and then 7 plus again 7 plus y, 7 plus y. So look at that. It's very simple. He said in how many years time? We're saying okay, it is y years time. Will the father's age, this is the father's age in y years time, and the sum of the children's, this is the sum of the children's age, they said equal to. Okay, so let's now solve this. This again is algebra. This is the reason why algebra is very important. If you want to learn about algebra, you can send me a DM. I have a very good course on algebra. Okay, understand algebra and make your life in mathematics very, very easy. So we have 36 plus y. Okay, so here we're going to have 2 plus y. We're going to just move the bracket, plus 4 plus y plus 5 plus y plus 7 plus y. Okay, so we're going to collect all the numbers together. We'll call them like terms. Numbers are like terms, letters, the same letters are like terms. So all the numbers, 2 plus 4 here, plus 5 plus 7. These are numbers. And then we'll collect letters. Y plus this y plus this y plus this y here. So 36 plus y will be 2 plus 4 is 6, 6 plus 5 is 11, 11 plus 5, 11 plus 7 is 18. There are 1, 2, 3, 4, 4y, so I have plus 4y. Okay, now all of these have now been simplified to this. We still have unlike terms because we can't add y to 36 here, and we can't add 4y to 18 here. Okay, so all we have to do is probably move the y's to one side and move the numbers to the other side. Okay, so here I'm going to move 18 to the left hand side. This 18 here is a positive 18. If I move it to the left hand side, I'm going to have negative 18. Once again, this is covered in your algebra class. You should know why that happens like that. And then if I move this to the left hand side, if I move 18 to the left hand side, what is left on the right hand side is 4y. And then I'm going to move this y to the right hand side now. Here is a positive 4y. If we move across the equality sign to the right hand side, it becomes a negative y. So what we're having right now is 36 minus 18, which is same thing as 18, because 18 plus 18 is 36. 4y minus y is like 4 minus 1. This is 4y. This is 1y. 4 minus 1 is 3, so I have 3y. Okay, remember that this is an equation. Okay, the left hand side is equal to the right hand side, so you can write it like this or you can write it like this. They are all the same thing. If 18 is equal to 3y, 3y is equal to 18, I just put the y's on the left hand side. So it's always good to put the letters on the left hand side. So I will divide both sides by 3 now. We have done this a lot of time. Okay, so 18 divided by 3. So if 18 is divided by 3, y becomes 6, because 3 times 6 is 18. So what we're trying to say is that in how many years time will the father's age be equal to the sum of the children's age? That will be in 6 years time. Let's see if that's correct. So if the father is 36 years now, okay, in 6 years time, the father is going to be 36 plus 6, which is around 42. Okay, Now let's check for the children in 6 years. 6 years time. Okay, in 6 years time, the one that was 2 years will be 8 years in 6 years time. Okay, the one that was 4 years in 6 years time will be 10 years. The one that was 5 years in 6 years time is going to be 11 years. The one that was 7 years in 6 years time is going to be 13 years. So let's add all of this. Remember they said the sum of the ages should be equal to the father's age. Okay, so 8 plus 10 is 18. 18 plus 11, here is a 9, 29. 29 plus 13, 9 plus 3 is a 12, carry 1. Here, that's 3 plus 4. You can see the sum of children's age gives us the same thing as the father's age. Daniel slept for 6 hours, 21 minutes and woke up at 7 o'clock. Daniel slept for 6 hours and 24 minutes and woke up at 7 o'clock in the morning. What time did he sleep? What time did he sleep? Okay, so we're saying that Daniel slept for 6 hours, 21 minutes. When he woke up at exactly 7 o'clock. 7 o'clock. So what we need to do right now is to know when he slept by subtracting 6 hours 21 minutes from 7 o'clock. So let's start with the whole number first. If you woke up by 7 o'clock, 7.00, and you slept for 6 hours, okay, so 7 minus 6 is 1. Okay, you can draw your clock there. Okay, it's very simple. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, these are not difficult things. Some children don't want to just put down something on paper. Okay, putting down things on paper can make you grab things fast. So he woke up at 7 and he slept for 6 hours. So count backwards 6 hours when he started. 1, 2, 3, 4, 5, 6. So he started. If we take out 6 hours, we'll stop at 1. Remember, we'll still have 21 minutes. Okay, so that means if we take out 6 hours, we are having that he started sleeping at 1. Okay, 1. If we now take away 1 from, if we take away 21 minutes from 1 o'clock, 21 minutes from 1 o'clock, okay, what will that give us? That is going to give us around 12:39. Okay, because there are 60 minutes. If we take away 21 from 60, 0 minus that is not possible. We take away 1 from here, 5, and then 10 minus 1 is 9, 5 minus 2 is 3. So this will now be 31 minutes left. Okay, since we are at 1, okay, the hour before 1 is 12. Okay, so it's going to be at around 12:39. So that is when he started sleeping, at 12:39. Okay, so if we have to put this in perspective of 7 a.m., he said Daniel woke up at 7 a.m. That means he started sleeping at 12:39 a.m. Okay.